Okay, so for this um homework, for the first question, we have to implement the function. This one right here, using the logic gate and a 4x1 multiplexer with C and D as a select signal. So, and then after that, we have to calculate the cost and the critical path delay of my solution. So here I have the truth table already for variable function right here. And here we have the product of sum. That's mean for the output is going to be 0 for every input. For this time is the maximum right here. So we will have 0 at 1, 2, 3, 5, 6, 8, 12, and 15. And for all others, spot is gonna be 1. All right, but because the question asks that we have to use C and D as the select signal, then I have to rearrange a little bit. But the output is still gonna be the same according to the table that we have earlier. And then after that, we have to find a function f in terms of A and B. As we can see right here, in order to find out the function output, I have to use the K-map, and the output is 1 when A is 0 and B is 0, and A is 0 and B is 1. So I get negate A. For this one, we can easily see that the output F is depend on A. And the third one is going to be the same at the above. Is the output is going to depend on A also. And for the last one, I have to draw the K-map out. And as we can see, is the output is 1 when A is 0 and B is 1 right here. And the output is 1 when A is 1 and B is 0. So I get A and B negate, or A negate and B. Now, after that, I have to draw out the logic gate. As we can see right here, we have, because C and D, we have to choose it as a select signal. We have 4 different group of CD. 1, 2, 3, 4. This is the first group when CD is both 0, 0. The second group when C and D is 0, 1 respectively, and the third group is when C is 1, D is 0, and the last is when C is 1 and D is also 1. So here is my multiplexer with this is C and D. Now, according to that function that we found up there, we will draw a logic gate for it. For 0, 0, for when CD is 0, 0, the input is going to be 8 negate. So I have A right here. Then I draw the gate. This is the NOT gate. Then go to 0, 0. This is A negate. And for when C is 0, D is 1, the input is going to be A. Here's the input. And for when C is 1, D 0, the input is also gonna be A. And for when C1 and D1, the input has to be A and B negate or A negate B. This has got a little bit more difficult to draw because now I have to use a B as an input right here, and I have to negate it. This is A and B negate. Now we have A negate B. This is A negate B. But the input function has to be A and B negate or A negate B. So that's why I need to connect these two using an OR gate. And then go to 1, 1. Here's our final logic gate. And then I have to calculate the delay path. So the delay path for the 4x1 multiplexers is 3 delta T. So the critical path delay is, you can see for right here is 3 delta T, and here is 3 delta T. So 3 delta T plus 3 delta T is equal to 6 delta T. And then we have to calculate the cost for this logical gate. Okay, here I have inside of the 4x1 mux. This is the inside of 4x1 mux. We easily see that we can easily calculate the cost of this mux. It has 2 NOT gate, and then 4 3 input AND gate, and then 1 4 input OR gate. For the cost of the NOT gate is 2, so 2 times 2 plus 4. Then the cost of the AND gate is 2 plus 2 times the number of inputs. So 4 go 2 plus 2 times 3. And the cost of the OR gate is also 2 plus 2 times the number of inputs. So it's 1 times 2 plus 2 times 4. So the total cost of the 4x1 mux is 46. And the cost of the circuit so the cost of the circuit is equal to these, and that plus the cost of the mux. So for the logic, we have the cost of the mux is already 46. And then we have 2 NOT gate is 2 times 2. And then looking back to the circuit, we have 2 AND gate with 2 input. So 2 times 2 plus 2 times 2. And then we have 1 OR gate, 2 input times 2. So in total, the cost is 68. Next, moving on to the question number 2, which is implement the function, this function, using the logic gate and 16x1 multiplexer. Use A, B, C, and D as the select signal. Okay, this is pretty. So I already have the truth table for 5 variable function given out. And then we have, it's gonna be the sum of product of 1, 2, 4, 6, 10, 15, 22, 26, and 27. Copy this down. That's mean as every of this place, the output is gonna be 1. Okay, so I numbered the state already. So it's gonna be 1 here. No, it's sorry. It's gonna be 1 here, 1 here, and then 1 at 4, 6 at 10, and then at 15, at 22, 26, then 27. And for every other place, the output is gonna be 0. 0, 0, 0, 0, 0, 0, 0, 0. For the rest. And because we using 16 by 1 mux, so I don't have to rearrange because the question said that we have to use A, B, C, and D as a select. So A, B, C, D as a select right here. And then E is gonna be out. So we have 16 different group of A, B, C, and D. Now we have to find a function f in terms of E. So by looking at this, we can see f is depend on E. So that's I get E, but here function the output is equal to the negate of E. This is gonna be the same thing. And this is also negate of E. And for this one, the function f is equal to 0 for every input of E. So that means it's 0. So, and this one is, the output's gonna be the gate of E, and this is 0, this is E, and 0, 0, 0, and the gate E, 0. And you can see right here, the output is gonna be 1 for every different E. It's gonna be 0 or 1. It's gonna be 0 or 1, but output is gonna be 1 for everything. Here, 0, 0. So I have 16 different group of A, B, C, and D right here for the 16 by 1 mux. Now that we have the function out, then I can draw the logic for it. So for the first one, A, B, C, D is equal to 0, 0, 0. The input is going to be E. The second one is E negate. Third one is also go up a little bit. It's also 1, 2, 3. This one is also E negate. When the fourth is also E negate. The fifth is 0. The sixth is E negate. And then 7 is 0. 8, wait, this is 7, this is 8, and this is 9. Wait, that's 0, 1, 0, 0, 0. Oh, wait. For easy, I'm going to write the input for each of these A, B, C, and D right here. So this is E, this is E negate, E negate, this is E negate, this is 0, this is E negate, this is 0, this is E, this is 0. This is just what I'm just doing by writing out the input for each group of A, B, C, and D according to the table above. Easy to keep track of. Oops. E 0, E 0, E 0, 0, 0. Oh, so this is E 0, 1, 0, 0. Okay. So for 0, 1, 1, 1, the input is gonna be E. For 1, 0, 0, 0, the input is gonna be 0. This is also 0. This is 0 also. This is E. This is 0, and for this one, it's gonna be 1, and then 0 for the rest. Okay, here's my logic gate using 16 by 1 mux. Thank you.